Hey there, Math Hoppers! In this video lesson, we are going to learn how to write linear equations in all of their forms. So let's begin. What are the different forms of linear equations? Well, let's start with the scariest. Point-slope form, the one we hate the most, but it's actually pretty helpful. It comes from the slope formula, as we'll see in a little bit, and it states y minus y1 equals m times the quantity x minus x1. Remember, y and x are just variables that are in the equation. x1 and y1 are given points, and remember, m is the slope. All right, so again, xy is any input-output value. They're the variables that are in the equation, and x1, y1 just refers to a specific point. Don't let it scare you or freak you out in any way. Okay, then we have slope-intercept form. This is the one everybody knows. We generally call it y equals mx plus b form. M is the slope and b is the y-intercept, and it's the friendliest of the forms. It's the one we like the most for sure. And lastly, we have standard form, ax plus by equals c, where a and b and c are all whole numbers, so they're integers, but a really should be positive. I'm going to say a needs to be positive, but I have seen in different textbooks where it doesn't state that at all, so that's why I have should be in italics. Your teacher may tell you that a should be positive. If so, they are correct. If they don't mention it and you're allowed to leave a as negative, okay, but really it should be positive. You should have a positive x value to start these. And they're usually used in word problems. All right, well, let's get started. So point-slope form, I said it's the one everybody hates. It's the one with the scary reputation, but it really does come from the slope formula, which at this point we all know. Okay, point-slope form is the easiest to use when you have a point and the slope of the line, hence the name point-slope form, right? All right, so let's see what I'm talking about. The slope formula is m equals y2 minus y1, or just change in y, divided by change in x, x2 minus x1. If we rearrange this, we can easily create point-slope form. And that's what we're going to do right now to show you that it's not too bad. Okay, so the first thing we want to do is clear this denominator, okay? Denominators, we kind of hate them. We hate fractions in all of their glorious forms. So we are going to take the first step and clear this denominator. If we want to clear this denominator, we need to multiply both sides of the equation by that denominator. So we're going to multiply both sides of the equation by the change in x, or x2 minus x1. When we do that, we will see that it divides out on the right-hand side of the equation exactly like we wanted, and we are left with m, the slope times the change in x, right? M times the quantity x2 minus x1 simply means m times the change in x equals the change in y. Okay, and that is point-slope form, but it's not really the form we all know, so we're going to flip it. Put the y2 minus y1 on the left-hand side because that's how we're all used to it. Just rearrange it so that it looks a little more friendly. Okay, so now let's talk about what's the equation of the line that passes through the points negative 2, 6, and 4, 2. Well, before we even talk about that, let's talk about how many different lines can we draw through 2 points. If I ask you to write an equation through, or equation of the line that passes through 2 points, is there only one? Well, let's see. We want to know how many different lines can we draw through 2 points. Let's plot these 2 points. There's negative 2, 6. There is 4, 2. Clearly, we can only draw one line through them. If we draw something through both of those points, that's just one line. There is not another line that I could draw that is straight, that is a line that would go through both of those points. I could draw some crazy concoction that would go through those 2 points, but only one line. Okay, so what does that mean? It means we can write the equation of any line given 2 points from that line. And that's exactly what we're going to do. All right, and I'm going to be honest with you. When they give you 2 points, there's only one thing you can do. Find the slope, and that's how we're going to start this. When they give you 2 points, the only thing you can do is calculate the slope. So remember, slope is change in y over change in x. If you haven't seen this yet, this little triangle means delta. It stands for change. So this little delta y over delta x simply means change in y over change in x. Don't let Greek symbols freak you out. There's no need for that. And it means this: y2 minus y1 equals x2 minus x1. And if you are unfamiliar with this little symbolism, go back and re-watch the slope and linearity video. We go over it several times in that video. Okay, so let's look at the change in y. Change in y, okay, so we're going to take, if we label this unofficially x1, y1, and this x2, y2, then the change in y would be 2 minus 6. The change in x would be 4 minus negative 2. Don't lose that negative. So 2 minus 6 is negative 4. 4 minus negative 2 is really just 4 plus 2. So you get negative 4 over 6, or negative 2/3. So what do we know from that? We know m is negative 2/3. Remember, we have this form called point slope that I said was most helpful if we had a point and a slope. Well, now we have the slope and a point. Well, actually we have 2 points, but we only need 1 point. When I taught high school, I used to tell my kids, remember when the bank manager in a movie would get kidnapped and they would need the code or the key to the vault or something from him. And once they got that, what did they do with him? Well, they got rid of him. So we had 2 points. We only needed 2 points to get the slope. Now that we have the slope, we have to get rid of one of the points, just like the bank manager. We only need 1 point. So what are you going to do? You are going to choose 1 point, either negative 2,6 or 4,2. It is your choice. You are going to take that point and you're going to take the slope and plug it into slope-intercept form. What is slope-intercept form? That was like 2 screens ago. I don't even remember. Okay, it's y2 minus y1 equals the slope times the quantity x2 minus x1. All right, what am I plugging in again? I'm plugging in m, and I'm plugging in 4, 2. 4 is going to be x1, 2 is going to be y1. So let's do this. M is negative 2/3, x1 is 4, y1 is 2. We get y2 minus 2 equals negative 2/3, x2 minus 4. And really how we would write this is y minus 2 equals negative 2/3 times the quantity x minus 4. We won't even have this subscript 2 anymore once we move on to new screens. Okay, just so you see where everything came from, our 2/3 or our negative 2/3 came from our slope. Our 4, that is our x1, that is the x coordinate of the point we chose. Our 2, well, that was the y coordinate of the point we chose. Why did we choose 4, 2? Probably because it had no negatives, right? You're not going to choose negative 2,6 when you have a choice of a point with no negatives. Okay, let's write another equation. Let's write the equation of the line that passes through the point negative 2, 3 with a slope of 1/2. Point slope form again, because I said point slope form was most helpful when you had a point and a slope. And looky, looky, we have a point and we have a slope. Okay, notice we lost the y2 and the x2. We only had that because remember we were working from the slope formula. So now we've really streamlined this into what point slope form looks like. Let's label everything, shall we? We know m is 1/2. We know x1 is the x coordinate of the point we're dealing with, which is negative 2. And y1 is the y coordinate of the point we're dealing with, which is 3. Let's plug everything in. Y minus 3 equals 1/2 times the quantity x minus negative 2. Remember, if your x or y is negative, you're going to wind up with a double negative within here, or within here if it was y. And that is always, always, always going to give you a positive. So we end up with y minus 3 equals 1/2 times the quantity x plus 2. Okay, let's take this equation and let's transform it into the highly popular slope-intercept form, or the y equals mx plus b form. But to do that, we will need a new screen. All right, so we have y minus 3 equals 1/2 times the quantity x plus 2. We have a perfectly good formula that is in point slope form, but we want to put it in slope-intercept form. And we can do that in 2 steps. First step, distribute that slope. You see this 1/2 times the quantity x plus 2. We are going to go ahead and distribute that. 1/2 times x will be 1/2 x. 1/2 times 2, well, 1/2 of 2 is 1. That's not too bad. Let's see how this looks. So we have y minus 3 equals 1/2 x plus 1/2 times 2 over 1. You might not need to put 2 over 1, but I put it there to show you. Let's simplify this. We will divide out our 2's and divide out our 1's, and we end up with y minus 3 equals 1/2 x plus 1. We are not yet in our favorite y equals mx plus b form. We need to get rid of that negative 3 that's on the left side with our y. So you move the constant, our second step, move the constant using inverse operations. What's the opposite of negative 3? Adding 3, or positive 3. So add 3 to both sides, we get y equals 1/2 x plus 4, and that is in fact in slope-intercept form, or y equals mx plus b form. Perfect. There is only one form we haven't talked about, and that is standard form. We really don't see this that often. We see it mostly with word problems, but it is a form and we need to know it. So let's use that last equation that is in slope-intercept form now and transform it into standard form. Let's remember, standard form. It's also called general form. Depending on how old your textbook is, you may see it written as general form. Standard form, general form, same thing. ax plus by equals c, where a, b, and c are integers, so those are whole numbers, positive and negative, and a is specifically positive. What is the equation we're dealing with? Y equals 1/2 x plus 4. Well, what's the problem? It's not in ax plus b, y equals c form. First of all, the x is on the wrong side of the equation. So let's take care of that. Step 1 is to move x and y to the left of the equal sign and the constant to the right. Well, so far, y is on the left of the equal sign and the constant is already on the right. The only thing out of place is our x term. So we're going to move that to the left side of the equal sign using inverse operations. So to move 1/2 x from the right side to the left, we will subtract 1/2 x from both sides. We will get 1/2 x plus y equals 4. Okay, next step. Remember, a, b, and c have to be integers. We have to clear any denominators. There are no denominators allowed in this form by multiplying by a common denominator. Your teacher or your textbook may say the least common denominator. Just multiply by a common denominator. It does not matter. You may have to simplify in the end, but that's okay. Let's multiply by 2 because 2 is the lowest and the common denominator we want to use. 2 times negative 1/2 x plus 2 times y equals 2 times 4. What do we get? Well, let's divide out our 2's. Don't lose our negative sign, right? We still have a negative x here. So we get negative x plus 2y equals 8. Remember we said a had to be positive? So our step 3, if a is negative, either multiply or divide by negative 1. The reason I say multiply or divide by negative 1, even though I know we will clearly just all divide by negative 1, is because multiplying by negative 1 gives you the same result as dividing by negative 1. So it matters not which one you do. And when you multiply or divide by negative 1, you simply change all of the signs to their opposites. So instead of negative x plus 2y equals 8, we get x minus 2y equals negative 8. Perfect. All right, let's try to write an equation from a graph. All right, writing an equation from a graph. You might think, well, we can just pick 2 points and do all the steps we've already seen. Sure, we could do that. I don't want to do that. That's more work than we need to do. So we could instead determine the slope, which is the rise over run, from the graph, and then locate the y-intercept and use slope-intercept form. So let's see what I'm talking about. What's our slope? Well, our rise, let's see. From this point here, 6, we go down 3, and we go over 2 to get to our next point. That gives us a slope of negative 3 over 2. Excuse me. What about the y-intercept? Well, that's just right there. We started from the y-intercept. Y-intercept is right on the y-axis. So let's pick it. Let's say it's 6. Now we have m and we have b. We could put this in slope-intercept form, our favorite form. Y equals negative 3x plus 6. All done. Easy peasy. Did not need to use the huge long equation of a line from 2 points. All right, let's look at another one. Let's write the equation of a line that has a slope of negative 2 and a y-intercept of 3. This is even less work than the last time. So we have the slope and the y-intercept. So slope-intercept form is the easiest to use. pop -2 in for m, and pop 3 in for b, and we get y equals -2x plus 3. Couldn't be easier. All right? Let's look at one more. Write the equation of the line that passes through the points 4, -2, and -2, -5. Given 2 points, your first step is to determine the slope. The only thing you can do from 2 points is find the slope. And then you're either going to use point slope form or slope intercept form, whichever is asked for or whichever you like more. All right, so let's do that. All right, 4, -2, -2, 5. Our slope is going to be -5 minus -2, so -5 plus 2, divided by -2 minus 4. So we get -3 divided by -6. Remember, negative divided by negative is a positive. We get a slope of +1/2. So now we have a slope and we have 2 points. Remember, we have to, what do we do with the bank manager, right? I used to joke with my kids in all those hostage movies that they would see. We'd say, one of my kids once said, what do you do when you have 2 points in a slope? Shoot a hostage. Just pick a point, right? You have the slope, you have 2 points. Let's choose 4, -2. So if we choose 4, -2, m is 1/2, x sub 1 is 4, and y sub 1 is -2. Plugging all of that in, we get y plus 2, because remember, we had a -2. So y minus -2 is going to be y plus 2 equals 1/2 x minus 4. Pretty easy, right? Point slope form, not that bad. Hopefully, I have showed you that point slope form is not as scary as you thought previously. Remember, if you have questions, if there's something on the quiz after this or on your homework or in a study guide or something that you're working on for class and it just doesn't make sense and you're writing linear equations, you should be subscribed to our YouTube channel. Submit those problems to us and we will make you a custom video solution that will show you how to do your homework. All right? Until next time, Math Hoppers, take it easy.